Ever try to get like a stubborn AI to make just a totally bizarre sound? Something like, saxophone barking.
Yeah.
Turns out
I can see that been tricky.
even some of the most, advanced AI models out there really struggle to create, just completely new sounds from scratch.
Right.
So today we're going deep on Fugatto. That's NVIDIA's pretty audacious attempt to kind of crack the code of this like generalist audio AI. We've got the research paper, obviously.
Right.
Demos.
Cool.
Even some like early reactions from the AI community.
Okay.
And let me tell you, things get
Okay.
pretty mind-bending.
So most of the audio AI that we've seen, so far is kind of like a one-trick pony.
Okay.
They're great at very specific tasks,
Right.
like text-to-speech or music generation.
Uh-huh.
But you give them something outside of their comfort zone,
Right.
and they just completely fall apart.
Yeah.
Fugatto's aiming for something way bigger.
Okay.
A model that can handle basically any audio task. And you can give it instructions in plain English.
So we're talking like telling Fugatto, make this sound more ominous like a haunted cello.
Yeah. Yep. Yeah.
Actually gets it.
That's the goal.
Wow.
And the key is how they trained Fugatto.
Okay.
They knew just, dumping tons of raw audio into it wouldn't be enough.
Right.
They had to teach it the actual language of sound. It's like teaching a little kid, to identify different instruments just by listening.
But how do you teach a machine something that's, so abstract?
Right.
It's not like you can point at a saxophone and say, this is what a saxophone sounds like.
Well, that's where things get really clever. Fugatto's training data isn't just a bunch of sounds. It's like this meticulously crafted symphony of instructions and descriptions and transformations.
Okay.
All designed to show the model this like intricate relationship between audio and the words we use to describe it.
Okay. I'm intrigued.
Yeah.
What does this symphony of data actually look like?
5 key ingredients.
Okay.
The first one is generating instructions using LLMs.
LLMs.
Those are the big, powerful language models.
Right, right.
So think of it like having all these AI poets, just crafting commands for Fugatto.
Okay.
Everything from simple things like synthesize a bird chirping to weird stuff like make this sound like a robot singing opera.
So they're like simulating how humans would talk to this audio AI.
Exactly.
And just throwing every instruction imaginable at it.
Yeah, and they didn't stop there.
Oh, there's more.
They also focused on both absolute and relative instructions.
Okay.
Which is super important for capturing like the nuances of how we perceive sound.
Wait, what's the difference between absolute and relative?
An absolute instruction is like straightforward.
Okay.
Like synthesize a happy voice.
Okay.
But a relative instruction is more about change.
Okay.
So it'd be like, make this voice sound happier or miss this melody more complex.
Oh, so it's all about how we describe sound compared to other sounds.
Exactly.
That's clever.
Yeah.
So we got LLMs, cranking out this huge library of audio instructions.
Right.
Some straightforward, some comparative.
Yep.
What's the next ingredient in this like sonic stew?
This is where things get kind of meta.
Oh, boy.
They used AI to analyze raw audio and generate descriptions for it.
So it's like they're teaching Fugatto to see sound by giving it these text descriptions of different audio characteristics.
Exactly.
So it's not just learning from instructions, it's learning to describe the sound itself.
Right.
That's why.
And by connecting these descriptions to the instructions, Fugatto starts to actually understand what different sounds are and how they relate to the language that we use.
This is getting deep.
It is.
Okay, 2 ingredients down. What's the next layer of this sonic lasagna?
All right, so this layer is all about being resourceful.
Okay.
They call it transmuting data outs.
Okay.
So imagine you have a data set of people speaking with different emotions.
Okay.
They transform this existing data to create a new task.
Okay.
Changing the emotion of a voice while keeping the words and speaker the same.
So they're like getting multiple meals out of one ingredient.
Yeah.
They're like AI culinary magic or something.
Right.
What's the 4th ingredient in this sonic feast?
This one adds a little spice.
Okay.
They used regular audio processing tools, like the ones musicians use to add reverb or change pitch. But instead of just giving the AI pre-processed audio, they taught it how to actually create and manipulate those effects.
So instead of giving Fugatto the finished dish, they're showing it the whole recipe.
Exactly, by pairing these modified audio samples with descriptions of what they did.
Yeah. Fugatto learns to understand sound transformations on a much deeper level. Okay, I see how this is coming together now.
Yeah.
4 ingredients down. What's the final element in this sonic masterpiece?
The 5th ingredient really ties everything together.
All right.
They use audio processing tools to create these pairs of audio samples specifically for transformation tasks.
Okay.
For example, they might take a dry recording and then create a version with reverb added.
Okay.
And then pair them with the instruction add reverb.
Oh, so it's like giving Fugatto before and after pictures.
Yes.
Along with the instructions on how to get from one to the other.
Exactly. And by sea of these pairs.
Yeah.
Fugatto learns not just what reverb means, but how to apply it to any sound.
Okay.
This is what sets Fugatto apart.
This whole comprehensive approach to data.
Right.
Yeah. Okay. So we got this incredible data set. But how does Fugatto actually process and learn from it?
Okay.
Does it just like follow it whole and magically become this, sonic genius?
Not quite.
Okay.
It relies on this unique architecture.
Okay.
Blending powerful techniques like transformer networks and something called optimal transport conditional flow matching. But what really makes it special is something called composable audio representation transformation, or composable art for short.
Composable art.
Yeah.
That sounds intense.
It is.
What's the deal with this composable art thing?
Well, essentially, it allows Fugatto to combine and manipulate instructions in a way that's never been done before.
Okay.
Imagine like a mixing board, but instead of adjusting levels for different tracks, you're changing the very essence of the sound based on these instructions.
Hold on. Are you telling me I can tell this AI to make something sound less happy by like subtracting happiness?
That's exactly what composable art allows.
Does that even make sense?
It might sound weird, but you can dial up the intensity of an instruction. You can blend multiple instructions together.
Sure.
You can even negate specific instructions to remove certain elements.
So instead of just following one instruction at a time,
Right.
Fugatto can blend and tweak them
Yeah.
to create something totally unique.
Exactly.
This is where it gets really interesting.
Yeah.
Tell me more about how this composable art magic actually works.
Composable art works by encoding the text instructions and the audio into like a shared.
Away. You are so vain.
No, I will be married in my uniform, as David is, she answered with a look Letty long remembered. Ah, okay, so there's no way to just dump onto Google Drive or something?
Mr. North, I'm sorry you should have had the trouble to come here, but will you let me go to sleep? Absolutely. I love a Prime and being able to buy whatever I want from the largest internet retailer in the world.
Kids are talking by the door.
Kids are talking by the door!
Well, as I say, they see life. Well, as I say, they see life.
Yo, it's Jensen on the mic, got the GPU flow, architects of the future. Oh, watch the power grow. Intelligence in the lab, learning every night. From tokens to code, humanity is taking flight.
Wait, did you see my H100s? Where did they go?
Deep learning is the key. We are unlocking the door. Tensor cores running, algorithms roar. We're leading the game. Ray tracing the world. No two friends the same.
Once upon a time in a land full of wonders.
Space.
Okay.
A kind of common language where sounds and words can, meet.
Okay, I'm trying to like picture this shared space idea. Is it like translating both language and sound into some kind of code that the AI can understand?
You're on the right track.
Okay.
Within this space, each instruction acts like a force, shaping the sound in a specific way.
Okay.
It's like having these sculpting tools that let you mold and manipulate the audio just based on your commands.
So if I tell Fugatto to make it sound happier and then add some ego,
Yeah,
it combines those two forces to create like the final effect.
exactly. And the cool thing about composable art
Okay.
is you can control how strong each instruction is,
I get it.
like adjusting how much pressure you use when you're sculpting.
Right.
You can blend them, amplify them, or even negate these forces to get like incredibly nuanced results.
This is blowing my mind a little.
Yeah, it's powerful stuff.
How do we actually go from like messing with these abstract forces in this shared space
Yeah.
to making real sound waves that we can hear?
That's where things get a bit more technical.
Okay.
Fugatto uses a process called optimal transport conditional flow matching to like gradually turn a random noise input into the desired audio output. Think of it like starting with a block of marble,
Okay.
and then you carefully chisel away until you have the sculpture that was hidden inside.
So it's not just putting together existing sound.
Right.
It's like creating something totally new
Exactly.
from nothing.
And composable art is like the conductor,
Okay.
guiding this whole transformation based on the instructions it gets.
So it's like having a master sculptor who can instantly turn your vision into reality.
Yeah, that's a good way to put it.
Okay, I'm trying to get the bigger picture here.
Cool.
But building something this complex couldn't have been easy.
Right.
What were some of the biggest challenges the researchers faced?
I think one of the biggest hurdles was just the sheer variety of audio data out there.
Okay.
Unlike text, which has a pretty consistent structure,
Uh-huh.
audio can be anything from speech and music to just random sounds in the environment.
Right.
Creating one model that can handle all of that
Yeah.
is a pretty massive challenge.
It's like trying to create a universal translator for the entire world of sound.
Yeah, exactly. And each type of audio has its own, quirks and complexities.
Okay.
Speech has rhythm and intonation. Music has harmony and melody.
Yeah.
Ambient sounds have texture and like spatiality. Capturing all of that in one model is a huge task.
So how did they manage to wrangle this sonic beast? Did they just throw every sound they could find at it and hope for the best?
Not exactly. They had to be more strategic
Okay.
about how they curated and processed their training data. Those 5 pillars that we talked about earlier.
That's right.
Those were key in teaching Fugatto the language of sound.
Okay.
The relationships between all the different elements and how they can be changed.
Right, those pillars.
Yeah.
So it wasn't just about how much data they had, it was about the quality and the variety.
Exactly. They didn't want Fugatto to just copy existing sounds. They wanted it to really understand how audio is structured.
Okay.
The basic building blocks of sound.
Right.
And how they could be, rearranged and changed to make something totally new.
And that's where all those clever techniques come in.
Right.
The LLM generated instructions, the audio captions, the transformation pairs.
Yep.
It wasn't just data. They were giving Fugatto a full sonic education.
That's a good way to put it.
It's like the difference between giving someone a dictionary and teaching them how to write a poem.
Yep.
One gives you the raw materials.
Right.
The other teaches you how to actually use those materials to make something meaningful and expressive.
Exactly.
That's a great analogy.
Thanks.
But I bet there were other challenges
Oh, yeah, for sure.
beyond just managing all of that data.
Yeah, one of the big ones was finding the right balance between the model's capacity and how computationally efficient it was.
Okay.
Larger models with billions or even trillions of parameters can create much more complex and nuanced outputs.
Okay.
But they also need a ton of computing power,
Right.
which is expensive and time-consuming.
So it's like choosing between a nimble sports car and a powerful truck.
Uh-huh.
Each has its pros and cons depending on what you need it for.
Exactly. They had to find a sweet spot.
Okay.
A model that was powerful enough to do what they wanted,
Right.
but also feasible to train and use.
And it seems like they found a winning formula,
Yeah, I'd say so.
but looking beyond just the technical stuff.
Uh-huh.
I'm curious about what they learned from the whole process.
Yeah.
Did any unexpected insights or challenges come up that might be useful for the future of audio AI?
One key takeaway was how important it is to understand how the different parts of the model all work together.
Okay.
They found that even small decisions,
Uh-huh.
like what method they use for sampling during training,
Okay.
could have a big impact on Fugatto's performance.
So it's not just about the big picture, the little details matter too.
Exactly. It's like fine-tuning an instrument. Even tiny adjustments can change the sound dramatically.
Right.
They also learned a lot about how the structure and variety of the training data affect what the model is capable of.
This is all super interesting.
Yeah, it's pretty groundbreaking stuff.
But let's zoom out for a second
Okay.
and think about the bigger picture.
Uh-huh.
What does Fugatto's emergence tell us about the future of creativity and human expression in a world where AI is playing such a big role?
That's the million-dollar question, isn't
Yeah.
it? Fugatto and other AI models like it are blurring the lines between human and machine creativity.
Right.
It makes us rethink what art is, what authorship means,
Mhm.
and the role technology plays in our lives.
Yeah.
It's both exciting and a little scary.
Yeah, it is a little scary, I mean, if AI can create basically any sound that we can imagine, does that devalue human creativity?
Right.
Are we reading towards a world where algorithms are writing the music and musicians are out of a job?
I get why people would think that, but I think it comes from a misunderstanding of what AI like Fugatto can actually do.
Okay.
They're not here to replace human artists.
Okay.
They're here to give them more power.
So it's not AI versus humans.
Right.
It's more like AI as a collaborator.
Exactly.
Like a super powerful instrument that artists can use to, kind of expand their creative possibilities.
Think of like a composer who's got writer's block.
Yeah.
Fugatto could give them new idea,
Okay.
suggest melodies or chord progressions they wouldn't have thought of on their own.
Right.
Or a sound designer working on a film could use it to create these unique soundscapes that match the director's vision perfectly.
Right. So it's like having a virtual brainstorming partner
Uh-huh.
who's always down to experiment and push the boundaries.
And as AI models like this get more advanced,
Yeah.
they'll open up even more creative possibilities.
Like what?
Imagine describing an emotion or a scene or even just an abstract concept.
Okay.
And then the AI turns that into a sound.
Whoa. That's pretty wild.
It is.
But what about the whole question of authorship?
Right.
Like if I use Fugatto to make a song, who owns the copyright?
That's a tough one.
Yeah.
And to be honest, the legal system is still trying to catch up to AI. Right now, copyright laws are mostly focused on human creators.
Right.
But as AI becomes more involved in the creative process,
Yeah.
we'll need to rethink those definitions.
That's like uncharted territory.
Yeah,
We're making up the rules as we go.
exactly. And it's not just about who legally owns something. It's about recognizing that human AI creativity is a collaboration.
Uh-huh.
We need new ways of thinking about it.
Right.
new guidelines that give credit to both the artist and the AI.
So it's like we're learning to dance together.
Yeah.
Figuring out how to move in sync and create something beautiful.
I like that.
Even though we don't know all the steps yet.
And I think as we get more comfortable with this dance, as we learn how to talk to AI and understand its creative potential, we'll discover completely new forms of art.
I can't wait to hear what those new forms sound like.
Me too.
But beyond just art,
yeah,
I'm also curious about how this tech will affect society as a whole.
Okay.
How might it change the way we experience sound and music in our everyday lives?
Imagine personalized soundtracks that follow you around, changing with your mood and your environment,
Right.
or being able to instantly turn any language into music.
Yeah. Whoa.
Breaking down cultural barriers and creating new ways to communicate.
It's like something out of a sci-fi movie.
It is pretty futuristic.
But even with all these possibilities,
Yeah.
some people might feel uneasy. If AI can create anything, does that make human expression less valuable?
Right.
Will we lose something important in the process?
That's a valid concern.
Yeah.
And it's something we need to think about carefully.
Okay.
But I truly believe that human creativity will always be at the heart of art. Tools like Fugatto are just extensions of our imagination.
Okay.
Instruments that help us express ourselves more powerfully.
So it's not about replacing human creativity.
No.
It's about amplifying it, expanding its reach.
Exactly. The way we use these tools, the stories we tell, the emotions we evoke.
Yeah.
That's what really matters in the end.
Hey there. Want to share your thoughts on this?
Sorry to interrupt. The paper said they replaced the transformer LP with the kernel size 3 convolutions. Can we figure out why?
Okay, let's unpack this. It sounds like you're diving deep into the nuts and bolts of Fugatto's architecture.
Yeah, you've picked up on a really crucial detail there. The researchers specifically chose kernel size 3 convolutions to replace the traditional transformer MLPs.
And just to be clear for everyone, the transformer MLPs, that's referring to the multi-layer perceptron that's part of the transformer model architecture.
That's right. And by using kernel size 3 convolutions, they're basically re-engineering how the model learns and processes sound.
Okay, so why make this change? What's the advantage of using convolutions there?
What's fascinating here is that it has to do with efficiency and how well the model can process audio. Convolutions are naturally better at picking up local patterns.
Okay, and I'm guessing these patterns are important in the audio world?
Absolutely. Think of them as tiny building blocks of sound. Using convolutions allows the model to focus on these details.
And it also sounds like it helps the model handle the data more efficiently too, right?
Exactly. It allows them to focus on what's most relevant and therefore use less computational power. It's a subtle tweak that adds up to a big difference.
Okay, so that gives us some real insight into the way Fugatto works. Thanks for that awesome question.
Yeah, that really highlights how much thought went into every aspect of this model's design.
Yeah, and as we were saying before the introduction, we were just getting into what they hope to achieve with Fugatto.
If we connect this to the bigger picture, it's about creating a truly general-purpose audio AI.
Yeah, what's the ultimate goal?
They want a model that understands and manipulates sound, as well as a human composer or sound designer.
That's a pretty ambitious goal.
It is, but it could revolutionize the way we create and experience audio, making it accessible to everyone.